Hello, virtual class. Today I will be presenting about the modern day human evolution, the evolution of the sickle cell anemia trait to combat the deadly malaria. First off, I want to give an explanation of what sickle cell anemia is and what it can do to your body. Sickle cell anemia is a mutation in the amino acid chain that codes for hemoglobin. Hemoglobin is the protein on the red blood cells that carries oxygen from your lungs to the rest of your body. When this mutation occurs, it transforms the shape of your red blood cells into a sickle shape. Here is a picture illustrating the sickle shape of the red blood cells that are affected by sickle cell anemia. As you can see, they're very different from normal red blood cells. These deformed red blood cells, which I just showed you, cannot carry enough oxygen to the rest of the body's tissues. This causes fatigue, physical deformation in children, miscarriage, fever, and severe pain. These symptoms can be fatal if you have the homozygous alleles for this trait. But on the other hand, if you have the heterozygous alleles for this trait, it only affects 40% of the red blood cells in your body, and it is not fatal. How does this relate to malaria, you may be asking yourself? It's a good question. Malaria attacks red blood cells in the body and multiplies inside these red blood cells until the red blood cells burst. And then it jumps to the next red blood cell and the next red blood cell and the next red blood cell and keeps bursting the red blood cells inside your body. And it kills roughly around 500,000 people every year. Interestingly enough, anthropologists discovered a correlation between the areas affected by malaria and the areas affected by sickle cell anemia trait. Here's a picture showing the areas affected by malaria. And here's a picture showing the areas affected by sickle cell anemia trait. Dr. Tony Allison was the first to document this discovery. He found when someone with a sickle cell anemia trait contracts malaria, the blood cells with malaria sickle up and flow through the spleen, which culls them out because of their abnormal shape. This carries the malaria, which is a parasite, out of the body with the sickle red blood cells. The reason African Americans have this sickle cell trait is because of the founder effect. Back during slavery, when we took West Africans from Africa and placed them in the United States against their will, they carried the trait with them to the United States, and it was passed on through generations. Now, one can predict that over time, the sickle cell trait presence will decline in America because, well, there's no real reason to have the sickle cell trait if there's no malaria in America. This mutation shows how adaptive fitness is related to specific environmental conditions. Even a lethal allele may be adaptive under certain conditions. In my opinion, this is a great example of the modern day human evolution, and it shows how our body can fight against a deadly parasite such as malaria. One can assume if malaria continues to spread, that the frequency and sickle cell anemia trait will also increase. And although malaria is treatable, it still kills roughly around 500,000 people every year. So it's still beneficial to have this trait in certain parts of the world, of course. Now, here's a list of my sources. And thank you all for listening, and I hope you all stay safe at home.